Hello everyone, in this video we will see allied angles. See the definition first. If sum or difference of two angles is 0 degree or integral multiple of 90 degree are called allied angles. Sum means plus, difference means minus. If you add any two angles or if you subtract any two angles, then if you get 0 degree, otherwise integral multiple of 90 degree if you get, then such type of angles are going to call it as what here? Allied angles. See, for example, you know the number system. So in the number system, here 0, this side if you go, you will get all the values are positive. Here all the values are what here? Negative. So this is nothing but what here? Integer numbers. 0, plus or minus 1, plus or minus 2, plus or minus 3, so on. All these are going to call it as what? Integer. So here, if sum or difference is there, for example, some angles I am going to consider, suppose 40 degree, 50 degree, 130 degree, 140 degree, okay, 230 degree, 300 degree, 600 degree. So these are some angles I am going to consider. So here I am going to add these two angles first. So if I add 40 plus 50, how much we will get? 90 degree, correct? So 90 degree means it is the integral multiple of 90 degree, because 1 into 90 degree is nothing but how much here? 90. Integer 1 is the integer number, correct? So such type of angles are going to call it as what here? Allied angles. But if I do 40 minus of 50, so that time you will get minus 10 degree. But minus 10 degree is not a 0 degree, or it is not what? Integral multiple of 90 degree. So remember, 40 minus 50 if you do, you are getting minus 10 degree. So this is not allied angle. Okay. So next if I take these two, I am going to take 40 and 130. So here 40 plus 130 if I do, I am going to get 170, correct? But 170, again it is not a 0 degree, again it is not integral multiple of what? 90 degree. So this is also not a allied angle. But if I do 40 minus of 130, so that time what will happen? 40 minus 130, you will get minus 90 degree. Minus 90 degree can be written as what? Minus 1 into 90 degree, correct? So now it is the integral multiple of what? 90 degree. Minus 1 is which type of number? Integer, correct? So such type of angles are going to call it as what? Allied angles. Again, one more last example, 300 degree plus 600 degree. If I add these two, how much I will get? 900 degree. 900 degree can be written as what? 10 into 90 degree. So again 10 is the integer number, so it is the integral multiple of what? 90 degree. So such type of angles are going to call it as what here? Allied angles. Okay. Otherwise, or the standard form of allied angle is n into 90 plus or minus theta. If theta is any angle, where n is which type of number? Integer number, then minus theta, 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, and 360 plus or minus theta are called what here? Allied angles. So if I substitute n is equals to 0, you will get plus or minus of theta. If I substitute n is equals to 1, 1 into 90 means 90 plus or minus theta. n is equals to 2 means 180 plus or minus theta. N is equals to 3 means 270 plus or minus theta. N is equals to 4 means what? 360 plus or minus theta. So such type of angles are going to call it as what here? Allied angles. Next, before knowing the trigonometric ratios of allied angle, first we will see some basic points. So in that, first one, so axis. So you know this is the axis, correct? XO, X dash is called X axis. YO, Y dash is called what here? Y axis. You know, in this axis here there are 4 planes are there. So 4 surfaces are there. These 4 surfaces are going to call it as what here? Quadrants. So this first surface is going to call it as first quadrant. This one second quadrant, like this third quadrant, okay, and here this is the fourth quadrant. So again in this quadrant, you know, if I go right side on the x-axis, here all the values are positive, here all the values are what here? Negative. Similarly, if I go upward direction, here all the values are positive, and here down all the values are what here? Negative in y dash. So remember, in the first quadrant, x and y both are what here? Positive. X is also positive and y values are also positive in the first quadrant. Similarly, in the second quadrant, if you come, here x comes what? Negative values. Here y comes in the positive value. So x is negative, y will be positive. Again, in the third quadrant, x and y both are negative values, because x dash negative, y dash is also negative. That's why x and y values both are what here? Negative. Similarly, if I come to the fourth quadrant, here x is positive, y will be what here? Negative, because x axis here positive sign, y dash is what here? Negative sign. So here x values are positive, y values are what here? Negative sign. So this is the first point. Similarly, in the second point, what you need to remember is, again in that same axis, if I draw one circle, again if I draw the right angle triangle in all 4 quadrants, so here this red line indicates the radius. In the first quadrant, this is the radius in the second quadrant, radius in the third quadrant, radius in the fourth quadrant. So here what I wrote, in first quadrant radius will be what here? Positive sign. And in the second quadrant, again radius remains positive. Third quadrant also radius remains positive. Fourth quadrant also radius remains what? Positive. So if I draw here one right angle triangle, okay, so if I call this is the ABC, suppose this value if I take -5, this BC value if I take 2, if I want to find out AB value, that time I am going to apply the Pythagoras theorem, correct? So if I apply, you know, Pythagoras theorem, AB square is equals to AC square plus BC square. AB square is AC plus BC square. So here AC value, what is AC value? -5 square plus BC value is 2 square. So you know here negative sign is there, but power is what? Even number. So minus also becomes what? Plus. So -5 square is 25. 2 square is how much here? 4. So you will get how much here? 29 AB square. Therefore AB value is how much here? Square root of 29. So what you can observe here, so if any one value is negative or both the values are negative, then after applying the Pythagoras theorem, this AB value again it becomes what here? Positive only, correct? Again this AB value becomes what? Positive. If you take any one negative or both the values are negative, again because of this Pythagoras theorem, again this AB value becomes what here? Positive only. So because of this reason, here this AB indicates what here? The radius, correct? Therefore that radius remains positive in all four quadrants. Next, third point. In the third point, remember again in the axis, in the first quadrant, 90 degree minus theta and 360 degree plus theta, these two angles are going to lie. In the second quadrant, 90 plus theta comes and 180 minus theta comes. Okay, in the third quadrant, 180 plus theta, 270 minus theta is going to lie. In the fourth quadrant, 270 plus and 360 minus. So 90 degree in radian is pi by 2, 360 is 2 pi, 180 is pi, and 270 is what? 3 pi divided by 2. See, suppose if I consider this angle theta is equals to 20 degree. So that time, so if I apply 90 minus theta and 360 plus theta and 180 plus theta, these two values I am going to apply. So 90 theta means how much here? Okay, theta means how much here? 20 degrees. So 90 minus 20 is how much? 70. 360 plus 20 is how much? 380. And 180 plus 20 is how much here? 200. So what you can observe here? See, 90 minus theta, if I take theta is equals to 20 degree, 90 minus 20 is how much? 70 degree. You know, 70 degree always lies in this first quadrant only, not in second, not in third, not in first. Therefore, and one more thing, 360 plus theta means 360 plus 20 is 380 degree. One complete rotation is 360 plus 20 means 380. It lies again in which quadrant? First quadrant only. Next, 180 plus theta I have taken. 180 plus 20 means how much? 200 degree. So till here 200, till here 180. Next, 200 means which quadrant it will go? Always in the third quadrant only, not in fourth, not in second. That's why remember 90 minus theta, 360 plus theta always lies in the first quadrant. 90 plus 180 minus lies in second quadrant. 180 plus 270 minus lies in third quadrant, and 270 plus theta and 360 minus theta always lies in fourth quadrant. And the next point you need to remember, fourth one. So in the first quadrant always 0 less than theta less than 90 degree comes. Second quadrant 90 less than theta less than 180. Third quadrant 180 less than theta less than 270. And in the fourth quadrant 270 less than theta less than 360. So if I start with 0, exactly here 90 degree comes, exactly here 180, here 270, one complete rotation is what? 360 degree. See, the meaning of 0 degree less than theta less than 90 degree means this angle theta always lies in between 0 to 90. That is the meaning of what? 0 less than theta less than 90, or else 0 less than theta less than pi by 2. 90 less than theta less than 180 means what? This angle theta lies in between 90 degree to 180. In between only this angle theta is going to lie. Similarly, in the third quadrant, 180 less than theta less than 270 means what? So it means 180 to 270, this theta is going to lie. Similarly, 270 less than theta less than 360 means in between 270 degree to 360 degree, this theta is going to come. So that is the meaning of 270 less than theta less than 360. So this is the fourth point you need to remember. Next, the one more last point, fifth point you need to remember is, remember in the first quadrant all 6 trigonometric ratios are positive. 6 trigonometric ratios means sine, cos, tan, cot, sec and cosec. all these are remains positive in the first quadrant. Next, in the second quadrant, sin theta and cosec theta both are positive, and remaining four are which sign? A negative sign, that is tan, cot, cos and sec. Next, in the third quadrant, tan theta and cot theta are positive, remaining four are what here? Negative sign, that is sin, cosec, cos and sec. All four are what here? Negative sign. Next, in the fourth quadrant, cos theta and sec theta remains positive, and remaining these four are what here? Negative sign, sin, cosec, tan and cot. So because, see, first I will tell why in the first quadrant all these 6 trigonometric ratios are positive. See, if I trace in the first quadrant, okay, if I trace in first quadrant one right angle triangle, in that right angle triangle, you know, if this is the angle theta, this is the 90 degree, means this is the opposite side, this is hypotenuse side, and this is adjacent side. If I take this point as P in bracket x comma y, that time this distance becomes x, this distance becomes y, and this is the radius, that is r. So you know this point in the first quadrant x and y both are positive. See, x and y both are positive, and in the first quadrant radius also remains what here? Positive. Therefore, if I apply the trigonometric ratios definition, you know sin theta, opposite divided by hypotenuse side. So that is opposite means y, hypotenuse side means r. You know y is positive and r is also positive, so positive divided by positive gives you the positive answer, correct? Again, if I take the reverse of this, cosec theta also becomes what here? Positive. Next, tan theta, opposite divided by adjacent side. Opposite means y is positive, adjacent side means x is also positive, so again positive divided by positive gives you positive answer. Similarly, cot, reverse of tan will be again positive only. Next, cos, adjacent side divided by hypotenuse side. So here adjacent side means x is positive, hypotenuse side means r is also positive, so plus divided by plus is plus only. Reverse of this is sec theta also becomes what? Positive. So what you can observe here, in the first quadrant all 6 trigonometric ratios answer you are getting what here? Positive. Therefore here all 6 trigonometric ratios remains positive only. Next, if I come to the second quadrant, in the second quadrant if I draw the right angle triangle, so this is the opposite side, that is y, this is the hypotenuse side, that is r, and this is the adjacent side, that is x. So you know in the second quadrant x is negative, y is positive, and radius remains positive. X is negative, y is positive, and this radius remains what? Positive. So here if I define the 6 trigonometric ratios, sin theta is opposite divided by hypotenuse side. Opposite means y value is positive, hypotenuse side means r value is also positive, so plus divided by plus is plus answer. Similarly, reverse of a sign will be what? Cosec theta also remains positive. Next, if I take tan, opposite divided by adjacent side, opposite is y is positive. Next, adjacent side means x is what? Negative, so plus divided by minus gives you minus answer. Therefore the reverse of tan is cot also minus divided by plus is minus, so these two are what here? Negative. Next, cos theta is adjacent side divided by hypotenuse side. Adjacent side means x is negative, hypotenuse side means r is positive, so negative divided by positive gives you negative answer. So reverse of cos is sec, also negative. So what you can remember here, in the second quadrant only sine and cosec I am getting what here, positive sign, and remaining all four I am getting what here, negative sign. So because of that reason, in the second quadrant the sine and cosec remains positive and remaining all four becomes what here, negative. Similarly, same process in the third quadrant. So again, if I draw the right angle triangle in the third quadrant here, so in third quadrant, you know, x and y both are negative, radius remains positive. Again, if I define the six trigonometric ratios, opposite means y value negative. Next, hypotenuse side means x value is r value is positive. Negative divided by positive is negative. Reverse of sign is cosec. Cosec also becomes negative. Next, tan theta, opposite side. Opposite side means y is negative. Next, adjacent side, x means also what here, negative. So negative divided by negative gives you a positive answer. So reverse of tan also becomes what, positive. Next, cos theta, adjacent divided by hypotenuse side. Adjacent side means x is negative. Next, hypotenuse side means r is what, positive. So negative divided by positive gives you negative answer. Reverse means plus divided by minus is minus. So here you can see only tan theta and cot theta are positive, remaining four are what here, negative sign. Therefore tan and cot remains positive in the third quadrant and remaining all four remains negative in the third quadrant, remaining four. Similarly, in the fourth quadrant, same process. Again, if I draw the right angle triangle here in the fourth, x is positive, y is a negative sign, and radius remains positive. If I apply the trigonometric ratios and definition, so that time you can observe sine theta, cosec theta, tan theta and cot theta, these four I am going to get what here, a negative sign, and only cos theta and sec theta I am going to get here positive sign. So because of this reason, in the fourth quadrant, cos and sec theta are positive, remaining four are what here, negative sign. Also, this you can remember by this short form, that is ASTC. So all these values gives you the positive answer only. All are positive. A stands for all. S means sine, reciprocal of sine remains positive in the second quadrant. T stands for tan and reciprocal of tan remains positive in the third quadrant. C stands for cos and reciprocal of cos remains positive in the fourth quadrant. And in second, third and fourth, the remaining four will be what here, negative sign. Shortly you can remember by ASTC rule. Next, trigonometric ratios of minus theta. So next one is what here, trigonometric ratios of minus theta. So here you can see sine of minus theta, answer is minus sine theta. Cosec of minus theta is minus cosec theta. Tan of minus theta is minus tan theta. Cot of minus theta is minus cot theta. Cos of minus theta is plus cos theta. Sec of minus theta is plus sec theta. Only these four are negative sign comes, and remaining these two you will get the positive sign, correct? So negative sign, and here you will get what, positive sign in trigonometric ratios of what, minus theta. Because see, if I take one axis, then here in the first quadrant I am going to draw one what, right angle triangle. So it is in the positive direction, means here theta I am going to take the positive. This point I am going to call it as what, P in bracket x comma y. So both are what here, positive in the first quadrant. So that time this x axis distance becomes x. here y-axis value goes to y. Okay, so next, if it is theta, so this is the opposite side. This is the 90 degree, means this is the hypotenuse side, and remaining side is what here? Adjacent side. Okay, so next, again in the fourth quadrant, if I draw one right angle triangle, so here I am going to take minus theta. So in a clockwise direction, if I rotate, whatever the angle is going to generate, all angles are going to call it as what here? Negative angle. So minus theta. So this point I am going to take it as p in bracket x comma minus y. So x is positive, y will be negative. So again here x remains x only. So y will be what here? Minus y. Correct. So if it is theta, this is the opposite side. This is the 90 degree, means hypotenuse side, and the remaining side is what here? Adjacent. So here if I use this right angle triangle, so that is sine of minus theta. Correct. So here you know the definition of sine of minus theta, sine of theta, opposite divided by hypotenuse side. Correct. Opposite divided by hypotenuse side. So you know opposite means which value? Minus y, divided by hypotenuse side is nothing but what here? I'm going to take this as r. Okay, radius I am going to take, that is r. So hypotenuse is nothing but what here? R. Correct. So this is from this triangle, but here from right angle triangle, if I call this is O P dash, here I am going to call P, this is M. So this is O M P dash. So next, from this right angle triangle OPM, here if I define sine of theta, opposite divided by hypotenuse side, so opposite is nothing but what here? Y, divided by hypotenuse is nothing but what here? R. Correct. So next what I'm going to do, I'm going to call this as 1. So next I'm going to substitute this y by r. You know y by r is nothing but what here? Sine theta. Correct. Y by r is nothing but what? Sine theta. So that time this 1 becomes sine of minus theta is equals to minus sign. I am going to keep it as it is, y by r. Y by r is nothing but what here? Sine theta. Correct. So finally what you are getting? Sine of minus theta is what? Minus sine theta. So sine of minus theta is minus sine theta. If I take the reverse of this, hypotenuse side divided by what? Opposite, you will get what? Y r divided by minus y. Correct. So that time you will get what here? Reverse. If I take cosec of minus theta, remains what? Becomes what here? Minus cosec theta. Next, same if I take tan theta. Wait. So tan of minus theta is equals to, you know, tan formula is opposite divided by what? Adjacent side. Okay, in this triangle, opposite means minus y divided by adjacent side means how much here? X. Okay, again this I am going to call it as 2. But from the triangle OPM, if I take here, tan theta is equals to, in this triangle tan theta is nothing but again same, opposite divided by adjacent side. Opposite is y, adjacent side is x. Correct. This value again I am going to substitute in 2. Therefore this becomes, you can observe, tan of minus theta is equals to minus, I am going to keep it as it is, y divided by x. You know y by x is nothing but which value? Tan theta. So here I am going to substitute tan theta. Therefore tan of minus theta becomes what here? Minus tan theta. Reverse of that is cot. So cot of minus theta will be what? Minus cot theta. Therefore, these all four remains what here? Negative sign. Next, if I take cos of minus theta from this triangle, cos of minus theta, you know cos formula is what? Opposite divided by, adjacent side divided by what? Hypotenuse side. So adjacent side is nothing but what here? X. Hypotenuse side is nothing but what here? R. Okay, again from this triangle, so if I call this as 3, from this triangle cos theta is equals to, again same formula. Here A means adjacent side is X and hypotenuse side is nothing but what here? R. Correct. So again, if I substitute this value in equation number 3, here if I substitute, so that time cos of minus theta is equals to, here x by r is there, x by r is nothing but what? Cos theta. Correct. So what you are getting? Cos of minus theta, you are getting what? Plus cos theta. Reverse means sec of minus theta will remain what? Sec theta. Therefore, remember, in the trigonometric ratios of minus theta, sine of minus theta remain will be minus sine theta. Cos of minus theta is minus cosec. Cosec of minus is minus cosec. Tan of minus theta is minus tan theta. Cot of minus theta is minus cot theta. And cos of minus theta is plus cos theta, and sec of minus theta will becomes what? Plus sec theta. Thank you.